Okay, now let's have our chapter 4 in thermodynamics. And the first law as our topic. Now our question. A piston cylinder device has zero point 0.8 kilograms of ideal gas in it. The gas is now cooled at a constant pressure until its temperature drops 10 degrees Celsius. Determine the gas constant and the gas's molar mass if 18.6 kilojoules of compression work is performed during this process. Also, if the gas's specific heat ratio is 1.667, find its constant volume and constant pressure specific heats. Now let's analyze our given with our mass at zero point 0.8 kilogram, our work at 18.6 kilojoules, our change in temperature at 10 degrees Celsius, and our specific heat at 1.667. Now we're tasked to find our gas constant, our molar mass, our constant volume, and our constant pressure. Now let's find our gas constant, and we can attain that by dividing our work all over our mass multiplied by our temperature. Inserting our given values, we'll have 18.6 kilojoules all over 0.8 kilogram times 10 degrees Celsius. And we'll have our answer of 2.325 kilojoules per kilogram Kelvin. Next, we'll find our molar mass, and we can attain that by dividing our universal gas constant by our gas constant of our given situation for our ideal gas. Now we'll be using 8.314 kilojoules per kilomole Kelvin, so that we can cancel our kilojoule and our Kelvin. So then we'll be left with kilogram per kilomole at 3.58. And that will be our molar mass. So now let's try to find our constant volume. Since our specific heat ratio is given, we can easily attain our constant volume by using the equation R, or R gas constant, all over K, which is 1.667 minus 1. Substituting our values, we'll have 2.325 kilojoules per kilogram Kelvin all over 1.667 minus 1. And we'll have 3.49 kilojoules per kilogram degree Celsius. Since it's the same with the unit of kilojoules per kilogram Kelvin, we can write it at this unit. Lastly, we'll try to find our constant pressure, and we can attain that by adding our constant volume and our ideal gas. So we'll just add 3.49 kilojoules per kilogram degree Celsius to 2.325 kilojoules per kilogram degree Celsius, and we'll have our constant pressure at 5.815 kilojoules per kilogram degrees Celsius.